Hello and welcome to State Matters. I'm your host, Matt Muratore. Today, we'll be discussing the weather. Joining me for that discussion is the Warning Coordination Meteorologist for the National Weather Service Forecast Office in Norton, Glenn Field. Glenn, thanks for joining me today.
Thanks for having me.
So I've done these shows for almost a decade now, and we always start off the show with who you are, and I found your background fascinating. So I'd like to spend a few minutes talking about who you are and talk about your background a little bit.
Well, thanks. My current position is the Warning Coordination Meteorologist at the National Weather Service here in Norton. It's the Southern New England Forecast Office. And that doesn't mean I have to be here for every warning. My job is to pretty much interface with all of our customers, and everyone's our customer. So that's mariners, aviators, emergency managers, the media, school children.
So how did you get into this?
So, well, let me just tell you, I give about 60 talks a year to all these different groups. And what's really...
Per year?
Per year,
right?
Yeah, not every day.
Yeah.
But the object being that people understand what our products are, how they can get them, all the watches and warnings, but most importantly, what they mean and how to respond to them, kind of like a disaster preparedness position.
Sure.
Or service coordination. In fact, they were going to call us the Service Coordination Meteorologist, but that would be SCUM, SCM. So
they're stuck with
warning coordination. They're stuck with Warning Coordination Meteorologist. But
WCM.
WCM. But what's really fascinating about my particular background is I've always been interested in the weather ever since I was 3 years old. My dad, I used to scotch tape the temperature to the door every hour and make my mother come look at it. A lot of us are kind of into it that way. But my dad was a ship's meteorologist in the Navy, chemical engineer in civilian life. And my mother was an elementary school music teacher. And now they were divorced when I was 1 year old. But I would visit him on the weekend, and he'd teach me all about the weather. Count to 5, it means that the thunderstorm is a mile away. Teach me about the state capitals, geography is very important. And my mother would get me interested in music and singing in the choir, acting in the plays. I was in a semi-professional production of Oliver and My Fair Lady. And it's kind of interesting.
And where was that?
Oh, back in New Jersey.
Back in New Jersey, yeah. Was it Cherry Hill?
Cherry Hill, New Jersey.
I spent some time in Ridgewood. My dad lived in Ridgewood when I was younger too, yeah.
Cherry Hill, New Jersey.
Yeah.
And that's actually it. I met my wife at the same high school in New Jersey. Right. So it makes the reunions easy.
Yeah, exactly.
But, anyway, so it's interesting that my job became a combination of the two. The science, the meteorology, and being in front of people and giving talks.
And you just got the bug at a young age.
Always interested in it. I
Yeah.
used to listen to radio stations early in the morning, late at night actually, and all up and down the East Coast listening for what the weather conditions were and trying to predict whether we'd have school the next day. And I was pretty good at it, actually.
Yeah, that's great. So tell us, you've been with the National Weather Service for 35 years. So tell us, you must know an awful lot about the National Weather Service. So tell us about the organization and what it is and what it does.
Okay, so the National Weather Service is part of the federal government. There are tax dollars paid for this talk.
Okay.
And so within the federal government, we're in the Department of Commerce. You might say, why commerce? But weather impacts pretty much every industry, shipping, transportation. So that's why we're there. And within Department of Commerce, the parent organization is NOAA. You may have seen little NOAA bird.
Yeah, and what does that stand for?
And that stands for the National Oceanic and Atmospheric Administration. So the oceanic part, we have the Woods Hole Oceanographic Institute, National Marine Fisheries, Stellwagen Bank National Marine Sanctuary. All of those are the oceanic part. But the atmospheric part is the National Weather Service, actually the biggest part of NOAA.
So NOAA falls under the National Weather Service?
No, National Weather Service is part of
NOAA, I see.
Which is part of Department of Commerce.
Got it, okay.
And so we're the biggest part of NOAA. And so our job here at the local forecast office in Norton, there are 122 forecast offices like this in the country, each with a Doppler radar. And our particular office is actually one of the bigger ones in the country because there are 13 what are called river forecast centers. and ours is the Northeast River Forecast Center. I'll get to that in a minute. But our jurisdiction area is pretty much, we're called the Southern New England Forecast Office, but the only state that we do all of is Rhode Island. We do all of Massachusetts except Berkshire County, and the reason is that their Doppler radar in Albany is closer to that area, okay. So they're served by the Albany office. And in Connecticut, we do Hartford, Tolland, and Windham counties in the northeast part of the state. Litchfield County in northwest Connecticut is the Albany office, and all of southern Connecticut is the Upton, New York office, again, because of the locations of the Doppler radars. Now, that's three different forecast offices in the state of Connecticut, and a job security for the warning coordination meteorologist.
Is there any north of Massachusetts, like New Hampshire,
Oh,
Vermont?
sure, yeah.
They each have one too?
The Gray Main Forecast Office handles all of New Hampshire. There's the Caribou and Burlington offices as well.
I was born in Caribou. I didn't know there was one there, okay.
So, yeah, so a lot of coordination takes place behind the scenes at the forecast office, making sure that you know, it is a national weather service, so we want to give one coherent picture, and we don't want to say it's a blizzard warning today. The Albany office thinks it's a freezing rain advisory, and the Upton office thinks it's not until the day after tomorrow. So there's a lot of coordination going on.
Yeah, I was going to say, so what specifically do you do, and what does the office actually do?
So what we actually do, I should have said before that our main mission in the whole weather service in general, it's very simple. It's the protection of life and property. And the one part that nobody ever says is the enhancement of the national economy, and hence why we're in the Commerce Department.
Makes sense, okay.
So at our office, we provide, of course, the day-to-day routine forecasts. You know, it's going to be sunny today kind of thing, so you know whether to wear a sweater. But our real bread and butter is the issuance of watches, warnings, advisories to protect people. You might have heard of a few of them, like a tornado warning,
Yes, yeah.
or a severe thunderstorm warning.
I was actually on Martha's Vineyard when that tornado warning came through. So
July
is that something that you guys coordinate with the warnings that go out to people?
Absolutely. I mean, that's really our main bread and butter. If we can save a life, that's what is really gratifying, and we feel like we did our job. And in fact, on that day is a great example, July 23rd, 3 Cape Cod tornadoes. And it was actually our best performance ever in terms of issuing a tornado warning. And here in New England, we get the smaller kinds of tornadoes. We'll talk about that a little bit more later. But the you know, to have a tornado warning at all in the first place is pretty amazing with the new technology and whatnot. But we had a 16 minutes of lead time from the time we issued the warning to the time it actually occurred
I was just gonna say
in
that,
Yarmouth,
yeah.
and 31 minutes for Harwich.
Yeah.
So we actually did
And
a good job.
I think it was almost 10 minutes on the island when I was there, and it was wonderful. I was doing some consulting work at the hospital there, but it gave everyone the opportunity to get the patients out in the middle of the hallway, away from windows and all that stuff. So I thought that was fantastic that it got that much of a notice.
Thank you. Yeah, we also heard from lifeguards that were able to clear the beaches in time, and many other situations like that.
Yeah.
Also in our forecast office, I mentioned the Northeast River Forecast Center, and what they do, there are 13 of those, and they're like a mini numerical modeling center right within our office. They provide us guidance specifically on rivers, having to do with how much rain has fallen, how much snow melt there is upstream, how much, what the type of soil conditions, and even releases from the Corps of Engineers from certain dams, tidal variations. All that goes into their numerical models, and then they tell us how much rain is needed in a certain amount of time to create a flood. But we do the actual river flood warnings. So they're providing us guidance. So it's great that we're co-located with them, because we can just walk over and ask for a contingency forecast. What happens if there's 4 inches of rain over the whole area, over all the basins? And they run their models. In a few hours, we'll have an answer, and we can inform emergency managers and things, you know, entities several days in advance, whereas the other offices have to call in for that information.
So when we're watching the major news stations, Channel 4, Channel 5, 7, 10, all that, and you're watching the weather, You talked about the Doppler. Are they getting the Doppler information from you, or do they have their own, or how does that work?
That's an interesting question. Some of the TV stations have their own radars.
Okay.
The National Weather Service Doppler radar is a $1.8 million radar system that was probably more accurate than some of the other radars. Reason being that it has a very narrow beam width. So what that means is that at long distances, that's what makes the radar so expensive. At long distances, it's kind of still focused into the storm, as opposed to a larger beam width. By the time you get out there, everything's averaged out, and you don't see the features that far away. So, but yeah, and a TV is one of the main ways that we get our word out. Obviously, TV meteorologists, we pride ourselves on having a great relationship with all the TV meteorologists in the area. We actually have them in our office, train them on interpretation of Doppler radar and things like that through the course of the year.
So weather-wise, what's the biggest threat to southern Massachusetts in our area?
So it's really fun to work in weather in New England because we get everything.
Bet, yeah.
Right? We get everything.
It must be boring, like if you go to Hawaii or you go to the islands, Aruba or something like that, or you go to Florida. I mean, it's just pretty much the same all the time.
Well, yeah, I mean, California is like fog and low clouds or low clouds and fog.
Right,
Which is,
right, yeah.
Either, I mean, not all the time, but
Yeah.
San Francisco area in particular.
Yeah.
But anyway, but here, so December, January, February, we're talking about winter storms, blizzards, coastal floods. Then March and April, we get into some snow melt and river flooding, maybe even ice jams on rivers. And then May, June, and July, that's our months for severe thunderstorms, tornadoes, gets hot and humid, all that kind of stuff, maybe even some flash flooding. Then you get into August and September, and we're talking hurricane season. Those are that's our months for potential hurricanes. It takes, in other parts of the country, they get it a little earlier. But ours, it takes that long for the waters to warm up south of New England to maintain them this far north. So usually August and September is our time frame. And we'll talk more about that in a little bit too. But, and then you get into October, November, and we're talking nor'easters, the Halloween, the perfect storm, those kinds of things, coastal flooding. Then you're back to December, January, and winter storms all over again. So we get everything. But if there was one thing that I would, that keeps us up at night, that is the most significant thing, is hurricanes. Got to be hurricanes. We don't get them very often.
Don't get them often, no. But,
And that's part of the problem, is that people kind of have this false sense of security around here. You know when the last hurricane was that actually hit New England?
Yeah, when?
Hurricane Bob back in 1991.
Okay.
So that's 28 years ago. And now Sandy sideswiped the area and technically wasn't officially a hurricane. We had Irene, was only a tropical storm when it made it this far. Those can be bad, but the last hurricane was 28 years ago. And the average return period for a hurricane of any type is 13 years or so. So we're due for a hurricane.
Overdue. Oh boy.
Now, the last major hurricane we had was Hurricane Carol back in 1954. And I wasn't born then.
Yeah, I've heard my dad talk about it. Yeah.
1961 I was born in.
Me too.
So that's where people don't, people of our generation, we like to say, have a warped sense of reality of what a hurricane can actually do. And I wanted to just take a few minutes here to talk about my hurricane spiel. And so Bob was a weak Category 2. Carol was a Category 3. That's considered a major hurricane. And there's a big difference between an ordinary hurricane, which is bad, and what a major hurricane can do. So studies have shown that a major hurricane, Category 3 for example, this is based on FEMA's
Is that what Puerto Rico had too a couple of years ago? Was that a hurricane? Was that a 3?
Yeah, that was, don't quote me on that, whether it was a 3 or a 4. It was big.
Yeah.
Yeah, a major hurricane is major means major. Sustained winds over 115 miles an hour. That's sustained, not just a gust. But imagine that, over a half hour, an hour, 2 full hours.
Yeah, like the recent one in Bahamas. I mean,
Well,
it
that
just
one
hovered
lasted.
over for a while.
That's really unusual. They last
Yeah.
24 hours. And that's actually one of the points I wanted to bring up is that the good news about New England hurricanes is, like Hurricane Bob is in for breakfast and out for dinner. They accelerate up the coast. And when they do that, they take on a structure that's entirely different than the kind that hit Florida, for example. Down there and in the Caribbean, what you read about, is perfectly symmetrical storm, where the wind and the rain blow furious from this direction, then the eye comes out, people go out and play tennis, but they shouldn't have because the rain and the wind come from the other direction very quickly thereafter. But our storms aren't like that. When they accelerate up the coast, they take on a really interesting structure, almost like a winter storm. And so, first of all the strong winds and the damaging storm surge and everything will be to the east of the storm. Because as the storm is moving up the coast from south to north, it's also in the same direction that it's translating. So all the strong winds, it's kind of had an additive effect on the east side. If you've ever been on one of those people movers at the airport, you walk in this direction and it's moving in that direction, you get there pretty fast. And so that's what happens on the east side of the storm. Whereas if you were walking on it in the opposite direction, it'll still get you there, but not quite as fast on the west side of the storm. So a great case in point is Hurricane Bob, 1991. Maximum sustained winds of 95 miles an hour moving northeast at 30. So to the east of the storm, and it moved up around the Cape Cod Canal. So east of the storm on the Cape and Islands, we had 125 mile an hour winds, 95 plus 30. On the west side, over in Foster, Gloucester, Rhode Island, 60 mile an hour winds, 95 minus 30, 65. The 1938 hurricane, which is the granddaddy of them all for New England, and I say that because it was a Category 3. It was 125 mile an hour sustained winds, but it was moving north at 60 miles an hour, racing north. So what do you get? 125 plus 60. The highest wind gust at Blue Hill Observatory, now that's up a little bit, but 186 miles an hour. So it works really well. That's our 3 rules of thumb for New England hurricanes. The first rule is forget about when they say it's going to make landfall. And that's all anybody's going to be talking about in the media. When is that storm coming ashore? But now that you've listened to this program, you know that because it's accelerating up the coast, all the important effects are going to be shunted way out ahead of the storm. And so 14 hours in advance of the storm is when all the strong winds and coastal flooding and everything's going to happen. And so if you're waiting for when the eye is going to make landfall, you're about 12 hours, 14 hours behind the 8 ball. Second rule of thumb is if you want to figure out where you are, you do have to know where you are with respect to the track of the storm. Because east of the storm, strong winds, storm surge, but west of the track is where the flooding rains will be. So that's a dichotomy for New England hurricanes. And the third thing is, as I've already said, if you want to estimate the highest wind gust at your house, if you're east of the track, you can add maximum sustained winds and the forward motion. If you're west of the track, take the maximum sustained winds, subtract the forward motion.
Wow, fascinating. So talk about with these storms, the Storm Ready program you have, and the other types of preparation and working with communities.
Okay. That's a great segue because the Storm Ready program, working with state officials, local officials, emergency managers, and so that just reminds me, I wanted to mention that with respect to hurricanes and working with the state, everyone should know their evacuation zones, and the Massachusetts Emergency Management Agency has on mass.gov/MEMA, you can get for your local town, it's called the Know Your Zone program. So People can look on there and see where they are with respect to evacuation.
That's good information. That's great. Yeah.
Thanks. Yeah, the Storm Ready program was developed out in the Midwest originally, but it's a nationwide program. And I work very closely with individual communities. As you know, in Massachusetts, we have 365 independent towns and cities, so that's a lot to work with, plus Rhode Island, Connecticut. But what's really great is, let me give you a success story. Out in Van Wert, Ohio, I think it was back in 2002, the small town of Van Wert with like 4,000 people had just gone through the Storm Ready recognition program. And what that meant, though, was that the emergency manager had given weather radios out to all the key places, the movie theater, and they had a plan in place so that if anything ever happened, tornado warning was issued, they get a confirmation call from the emergency manager, they'd hear it on the weather radio, and they knew exactly what to do. Well, little did they know that about 5 months later in November, an EF4 tornado tore through the movie theater. Now, out in the Midwest, they had 28 minutes of lead time, very similar to what we had with Harwich, but this was an EF4 tornado. Harwich was an EF1, but still, tornadoes important. There are pictures of the cars that were parked outside that landed on top of the seats at the movie theater. But no one was injured because they all got the word and they went into a reinforced bathroom. That's a great success story of the Storm Ready program. So in a nutshell, what it is that, of course, no community can ever be storm proof. But Storm Ready means that they've done everything they can do to be prepared. So there are requirements to have multiple ways to receive warnings, to disseminate the warnings. They have to have equipment, weather equipment that monitors local conditions. And most importantly, everyone in the town, the police, the fire, the DPW, everybody's working together and they're weather savvy. And they know, for example, how to go onto our website. And
Is that what they do? They go onto your website?
Sure.
These towns?
I mean, they can find our forecast discussion. We're one of the few government agencies that lays it all out there. We write a detailed discussion, tell you our confidence in the models and why we're forecasting what we're forecasting. And we even have 50 versions of it. So if you're taking a bath at night and you have nothing else to do, you can read the 50 versions and see how we've changed our thought processes. We're getting more convinced that it's going to be a big storm. So it's a recognition program and a way to notify citizens via reverse 911 or things like that. So there are towns, there are universities that are storm ready, there are commercial sites. I'd be happy to know that Six Flags theme park, for example, is storm ready. They have their own lightning detection system and start shutting down the big rides when lightning's within 10 miles away. That's what the storm ready program is.
That's great. You were talking about tornadoes, but we hear a lot about microbursts and downbursts, and we saw a water funnel when I was on the island for that last tornado. What are those compared to tornadoes?
Well, that was a water spout.
Water spout,
is a tornado over the water, basically. There are different types of water spouts. There are some that occur in fair weather, just beautiful weather, and they just sort of form from a lot of instability, but they don't have, but they tend to be weak with only like 40 to 60 miles an hour. And if you're a mariner, you can actually maneuver around them. That's the fair weather kind of water spout. But what we had that day was actually what's called a tornadic water spout. Forms from the same conditions that a real tornado would form over the water, and when it moved over land, it was maintained itself because it was formed by strong atmospheric conditions. And so those are very dangerous. And we reached out to a lot of places, including the Steamship Authority, which some of those ships were actually right in the path.
It was in the path, yeah, I remember that, yeah. So what's a microburst then?
So, right, a tornado is a rotating column of air in contact with the ground. If it's not in contact with the ground, we call it a funnel cloud. But that's different, and it's low pressure. Everything blows in toward low pressure. A microburst is the opposite. It's what we call a downburst. Every thunderstorm has an updraft and a downdraft, but a downburst is an incredibly strong downdraft. And a microburst is a subset of a downburst. It's like if the damage is less than 2.5 miles, we call it a microburst. If it's more than 2.5 miles, it's a macroburst. The generic term is a downburst. But we call that straight line winds because as viewed from the air, or if we go in a damage survey, you'll see everything spreading out. It comes down and spreads out. That's how we can tell it's a downburst or a microburst. But with a tornado, it's low pressure and everything blows in. So you would see trees blowing in toward each other and things like that.
I see. Okay. Okay.
Good. I'm sorry.
Okay.
Yeah, we get a lot of tornadoes, maybe 1 to 3 per year is the average in southern New England, but they tend to be weak. But once every 10 years, we get the real big ones, Midwest style. The last big one that we had was 2011 out in Springfield, Munson. So like an EF3 tornado.
Yeah, yeah. We only have about a minute or so left, but
Okay, we'll be real fast.
Farmer's Almanac. How accurate is that every year?
I
People
can't
seem to
comment on
depend
that.
on it. You can't, okay. What's the prediction for can you predict weather out like for this winter in this area? Can you look at that and see or no?
Not really either.
Yeah,
It's a
no.
kind of actually
How
climatology.
far out can you look at for weather?
The meteorology is about 7 days.
Okay,
We make a
okay,
forecast out
okay.
to 7 days.
Yeah.
Climatology is actually a whole different profession.
Okay, okay. Yeah, because obviously we're dealing with more climate change nowadays, and whether you believe it or not, I think climate change is real. I just did an editorial on it not too long ago. But you're seeing a lot of weather changes throughout the country, everywhere, but particularly this area.
But weather does come in cycles. We've had bad years. 1953 had the Worcester tornado. 1954 we had Carol and Edna. 55 Diane and Connie. So those were pretty bad years. They can come in cycles. So
Yeah, yeah. Well, this is fascinating. I want to thank you so much for coming on the show today and explaining how the weather works, and thank you for all you do and 35 years of service for the National Weather Service. We really appreciate that.
thanks for inviting me.
Yeah,
If I could
sure.
do a shameless plug of weather.gov/Boston. That's how you get to our office.
Perfect, great, thank you so much. Well, I want to thank Keith and Ben and all the folks at PAC TV for another terrific show and for all they do for our community. I also want to thank you at home for watching. We'll see you next time on State Matters.